Hello students, in this video we'll be starting with the chapter on constructions, and in this chapter we'll be learning to divide a line segment in a given ratio. And to begin with, we'll be learning to construct a triangle similar to a given triangle as per given scale factor, which may be less than 1 or greater than 1. So let's begin with exercise 11.1, and the first question says draw a line segment of length 7.6 centimeters and divide it in the ratio 5:8. Measure the two parts. So what we need to do first is we'll have to draw a line, okay, and in order to divide it, we'll have to divide it into two ratios, that is one will be 5 and the other one will be 8 in this, so into 13 units. But this entire line, total line, will be of just 7.6 centimeters. So what we'll do first is we'll just draw the 7.6 centimeters first to begin with. So draw the 7.6 centimeters, which is till here, out here, from here. Okay, so that's 7.6 centimeters. We'll just mark this as A and B. Next, we need to draw an acute angle from A. It can either be on top or bottom. Since we have less space on the top, I'll just draw it down. You can do it on top as well. Please bear in mind, it has to be an acute angle this way. Okay, that means less than 90 degrees. It doesn't matter what is the angle over here, it just has to be less than 90 degrees. So mark this as an angle. Now our next step would be to construct 13 units along this line. So they should be of equal length. Doesn't matter whether it is 1 centimeter, more than 1 centimeters, or less than 1 centimeter, but they all have to be 13. Why 13? Because see, we need it in the ratio 5:8. If we add this 5 plus 8, we get 13. So to divide it into 5:8, that means the total units on this particular length of 7.6 centimeters should be 13 units. Now you may say 7.6 centimeters is this, then why are we drawing this? We'll come to that part later on. Let us first do what is required, that is construct 13 units. So I've already taken the units. So you begin first with here, keep your pointer over here, and I'll cut an arc. Okay, so that's our first arc over here, and from that point we'll construct the next one this way, and then I keep constructing till I have 13 of them. So wherever the arc cuts the previous line, that becomes my new one here. So something like this way. Okay, I've constructed over here 13 arcs, which means I've cut 13 this line into 13 parts. Next, what I need to do is I need to join B to this last arc. I'll do that this way. Okay, and over here, which is A, I'll give that after this, the cuts that I've got over here, I'll give them names B1, B2, B3 and so forth. So this will be B1, B2, B3, B4, B5, B6, B7, B8, B9, B10, B11, B12 and B13. Okay, now we need to cut this line into the ratio 5:8. So where is the fifth one over here? Is B1, B2, B3, B4 and B5. So from here to here, okay, we'll have to draw a line similar to the one that we have from B to B13. But we need to draw a line that is parallel to this B to B13. Okay, so in order to draw a line that is parallel to B to B13, what I'll do first is I'll take a measurement from B13, is draw an arc. Okay, let's see from here, I'll extend it a little further and cut this line and cut the top line as well. Okay, now from where I want a line to be drawn parallel, that is from B5, using the same measurement that I used to draw an arc, now I'll draw another one this way, and now I'll take the measurement from this B12 here till here. So this arc I'll measure, okay, and I'll keep my pointer over here wherever it has cut the line, the arc has cut the line or intersected the line. Sorry. And I'll cut this arc this way. Mark the point where the two arcs intersect, and from B5 draw a line that goes through that point this way. Now this line is parallel to this B13. Now that we have drawn this line, we'll mark this as C, and we are asked to measure the two parts. So this two parts should be in the ratio 5:8 now. And let's see the measurement. AC is 3 centimeters and CB is 4.6 centimeters. So we know that AC upon CB is 5:8. So now if we want to justify how do we get this, then we'll go back to our basic proportionality theorem. According to the basic proportionality theorem, we have learned the basic proportionality. Something like if we have a look, then this will look familiar to where we applied the basic proportionality theorem, where it says if there are two parallel lines, okay, and one parallel line is cutting two sides of a triangle, then what happens is this side upon this side is equal to this one upon this. So which means if we apply the basic proportionality theorem, so we say by basic proportionality theorem, since B5C is parallel to B13B, we can say that A B5 upon B5 B13 is equal to AC upon CB. From A to B5 are how many units? 5. So instead of AB5, I put 5. And from B5 to B13 is how many units? 8. So instead of B5, B13, I'll put 8. So this we find is equal to AC upon CB. Exactly what we mentioned over here. So this is what we needed to do. This is a justification for whatever we have constructed to show that, okay, after constructing so and so, this is how we get indirectly we divide the line segment AB in the ratio 5:8. So that solves the construction of the first question from exercise 11.1. So if you like watching this video, please hit the like button, share it with your friends and classmates. Please subscribe to the channel and do not forget to click on the bell icon. Thanks for watching. See you in the next video.